Hey everybody, I just wanted to show you a few more examples of simplifying rational expressions like this, as well as there's one question on the homework that asks you to state the restrictions on the variable. So what that really means is we have to figure out what values of x or whatever our variable is that we need to exclude so that we don't end up dividing by zero, which is something we can't do. So looking at this, the first thing I'm going to do is factor. So I'm going to rewrite this as, let's see, I'm looking for numbers that multiply to 12 and add to 7, so that's 4 and 3. This is x plus 4 times x plus 3 on top. In the denominator, I'm looking for numbers that multiply to 6 and out to 5. That's 2 and 3. So I'm going to have x plus 2 times x plus 3. Now, before I say that the x plus 3 is divided to 1 and essentially cancel them out, I'm going to make sure to exclude any values of x in the original expression that end up making me divide by 0. So I want to exclude both where x plus 2 is equal to 0, which means x is equal to -2, and x plus 3 equal to 0. So x equal to -3. So those are the things I have to exclude. So after I finish simplifying this, I'm going to write x cannot equal -2 and cannot equal -3. So now I can see the x plus 3's cancel. So this is equal to x plus 4 over x plus 2. And then I'm going to say that x is not allowed to equal -2. That's still kind of obvious because if you plug in -2, you get 2 divided by 0, which is undefined. But we also can't let x equal -3 because even though it's fine here, it wasn't fine in the original expression. If you plug in -3 here, you get 1 times 0 over -1 times 0. You get 0 divided by 0, and 0 divided by 0 is an indeterminate form. It can actually be any value. So 0 divided by 0 is a problem we'll deal with in calculus. For now, it's just we can't finish the problem. So -2, -3 have to get excluded from the domain or the restriction on x. Look at the same thing down here. So again, I'm going to start by factoring. So I'm going to rewrite this or factor this as well. Actually, I'm going to do something first. I'm going to write this as a difference of cubes. This is x cubed minus 3 cubed. This is the difference of squares. X squared minus 3 squared. For a difference of squares on the bottom, we know the difference of squares factors is the first thing minus the second thing times the first thing plus the second thing. For a difference of cubes, we know that it's still the first thing minus the second thing, but then the next part is the first thing squared plus the first thing times the second thing, or the second thing times the first thing, plus the second thing squared, right? It's that whole a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. And similarly, a squared a cubed plus b cubed, the sum of cubes, is a plus b times a squared minus a times b plus b squared. And finally, a squared minus b squared, a difference of squares, is always a minus b times a plus b. So we see that the x minus 3 are going to cancel, but again, before we do that, we're going to note that x can't equal +3 and x cannot equal -3. So when we end up getting this, we get x squared plus 3x plus 9 divided by x plus 3, and we're going to say that x cannot equal 3, x cannot equal -3. We factored it and simplified it as possible. Now, I'll point out, they're not asking us to do this, but this could also be the beginning of a polynomial division type of problem. So just to be aware, there is more we could do here if we were being asked to, but that's not what the problem says. We're just simplifying and stating the restrictions on x. These next two, we're not going to state the restriction on x, although we certainly could if we wanted to. What I want to point out is that whenever you have rational expression division, I think I should fix my camera here a little bit. I think the first thing you should do, or I should do, is instead of saying this divided by that, I'm going to rewrite it as x squared minus 6x divided by x squared minus 36 multiplied by the reciprocal of this. That's going to be 2x squared plus 2x minus 60 divided by x squared minus 25. Now, I do think I also probably could have done some simplifying in that first step, but I didn't want to make it more confusing. So now we'll start simplifying as much as possible. So from each factor, well, the x squared minus 6x, I can factor out an x with x times x minus 6. From the x squared minus 36, that is a difference of squares. It's x squared minus 6 squared. So I'm going to write it as x minus 6 times x plus 6. Over here in the numerator, I have a greatest common factor of a 2, left with x squared plus x minus 30. In the denominator, x squared minus 25 factors is x minus 5 times x plus 5. Now you see that I can divide the x minus 6 to give me a 1. So I'm going to rewrite this. I'm actually going to write the 2 in front of the x, and I'm going to start multiplying these together. So I'm going to have a 2 times the x, and then the x squared plus x minus 30 factors as x plus 6 times x minus 5. I have an x plus 6, I have an x minus 5, I have an x plus 5. The x plus 6 is divided to 1, the x minus 5 is divided to 1. I'm left with 2x divided by x plus 5. So that's a little trouble. There's nothing more I can do as far as simplifying. Trying to write the x a little better there. Sorry about that. Yeah. Similar thing here. Before I start doing things, so actually I'm going to do two things at once. I am going to write it as two fractions multiplied together. So this divided by this. Actually, I'm just going to do one thing. X squared plus 5x plus 4 divided by x cubed plus x squared multiplied by the reciprocal of what I'm dividing by. It's kind of like how you say if you're dividing by 5, you're the same as multiplying by 1/5, or dividing by 2 is the same as multiplying by 1/2. That's generally true. Whenever you're dividing by something, it's equivalent to multiplying by the reciprocal of that something, which is why we can't divide by 0, because 0 doesn't have a reciprocal. So here we're going to multiply by x squared minus 3x over x squared minus 16. Now we're going to simplify, or we're going to factor, I guess. I mean, simplifying is kind of a very broad term. So x squared plus 5x plus 4 factors is x plus 4 times x plus 1. At this point, you can either write it in one fraction or two. Like I can either write this fraction times this fraction, or I can write this top times this top. That top factors is x times x minus 3. Careful, that's an x there, not a multiplication symbol. In the denominator, I have x times x squared. Sorry, I have an x squared times x plus 1. And I have an x minus 4 times x plus 4. And it's fine to write it like this or separate like this. Either way, we're still conveying the same information. And now we can cancel things. So let's see. So I can cancel the x plus 4s, or divide the x plus 4s to 1. The x plus 1s also divide to 1. I'm doing it in both spots. Doesn't really matter where I do it. And then lastly, x over x squared, I can essentially divide one of those away and be left with just an x in the denominator. Or if you prefer, right, x to the first divided by x to the second. If I bring that x to the first down to the bottom, it's x to the negative first. So I can rewrite this as x minus 3 on top over x squared times x to the negative first, right? That's coming down to the bottom as that. And then I still have an x minus 4. X squared times x to the negative first is just x. So I can rewrite this as x minus 3 divided by x times x minus 4. All right, those are just a few quick examples. Make sure you're on board with this. And yeah, that's all I got. I'll see you tomorrow.